So good morning. How many students? Very less today. So why they are very less? They are doing study. Only eight. So nine. So very less number is today. So everyone, I think, having the information regarding the test that will be conducted tomorrow. So in third lecture that we are going to organize that test two, that is 301 and 302 we will take tomorrow, and 303, 304 and 305 that we will take day after tomorrow. So that is the schedule. I think everyone know the schedule, and just we have to check how the link will be provided to you. Within that minute you have to complete. So you have already experience with you, and after that the tentative schedule is also already display that in the next month there will be ISE, and this is the internal evaluation, that is day to day performance. So the marks of this test is also counted, and we have to submit to COE. So already first we have already submitted. This is the second one that we are giving the unit test. So you may aware regarding the such kind of test in a online manner, because it is very difficult to say whether we will go offline immediately. So probably this semester will be go to the uh, in a online mode. So it is very essential that each and every activity you should be participated. Also you have to see various other activities are also going on the basis of PDP 3, P4 research project, then some other courses, add-on courses. So such kind of things are also going on. So you should participate in that, because that having some credit also. So be check that which in which you have participated. I think everyone try to participate at least one activity. So that is very essential to take participation. So today we're going to probably finish the this topic. As on the last lecture we have seen the number of analyzers as well as detectors. And we also focus on some parts that include analyzer as well as detector, and in that we have explained the very important, that is the tandem mass spectrometry, in which generally the TOF, then FTICR, then quadruple ion. So that technique, when they are attached to the mass spectrometry, then they act as a tandem mass spectrometry. So just we will focus on that part. That is the what is the tandem mass spectrometry. So we have to purpose to fragment ions from parent, so that can provide the structure information. But this is the only first part. So in the tandem mass spectrometry we have to allow the mass spectrometry, that is the separation of all fragment ions, as well as the that can also allow the identification of compounds in complex mixtures, mostly in proteins, carbohydrates. So for that purpose, this tandem mass spectrometry is very essential. So here we can use more than one mass analyzer, all filters. So that is nothing but up till now we have seen the number of mass analyzers. In the tandem mass spectrometry, we have to use in number of times. Like quadrupole, we have seen that triple quadrupole. So that is nothing but in quadrupole there are four poles are there. Like that in three quadrupole, they we use a three such kind of quadrupole system, that is q1 q2 q3, and between that there is a collision which takes place, and that gives a very fine fragmentation pattern, and that is very easy to identify the compounds from the complex molecule, complex mixtures. So here that can be carried out. The collision cell is there in between with having argon or xenon. So collision cell is where the selected ions are sent to further fragmentation. So fine fragmentation pattern is observed in the tandem mass spectrometry. So that is the very important part of the mass spectrometry. So if you observe, mostly it is applicable for the proteins, carbohydrates, lipids. So mostly for biomolecules, this tandem mass spectrometry is very essential. So this is the our regular mass based peak, and it is very difficult to identify the fragment. But when we can take any one, suppose here we can observe this is the only one peak here we have to consider, and this peak, when it attach or pass through the, or that ion is passed through the quadrupoles, that is triple quadrupole. This is quadrupole 1, this is quadrupole 3, and already there is quadrupole 2 is there, and between that there is a collision cell is there. And then in it, if you observe, this is a single molecular ion, then it undergo fragmentation in the q2, and then again it passed through the q3. Then we can observe the number of lines are increases. So that indicate the fragmentation is increases. Further molecular ion or that fragment ion is undergo fragmentation, and we can obtain a very fine signals m by z, and from that we can very easy to identify the molecules. So in that case we have observed this is a tandem mass spectrum. So theoretically we can say that is by using the computer sequential database, if you have, then for that particular molecule or that particular complex, which is the m by z ratios we have observed, or which mass and peak we can observe, that theoretically they can be predicted. So here by using such kind of technique, we can observe the identification, and protein identification takes place very easily by using the tandem mass spectrum. So that is the use of why there is a need of tandem mass spectrometry. So generally in the tandem mass spectrometry, the distinct ions of interested are selected, that having a particular m by z, which is found in the first ms, that is mass spectrum, and then it further undergo fragmentation by number of methods of dissociation. No doubt there are so many methods are there to undergo fragmentation further, or we can call it as dissociation further of that particular fragment ion. So one such method involves colliding the ions with the spectrum by using a inert gas, that is argon and xenon, which is known as collision induction dissociation. So this is one of the way, that is CID. There is also one of the way, that is higher energy collision dissociation, HCD. And along with that, no doubt these two are commonly used. Along with that, other methods are also used, that is ion fragmentation include electron transfer dissociation, that is ETD, and electron capture dissociation. So the transfer of electron or capture of electron is takes place. So the number of fragment is uh, observed on the basis of transfer of electron as well as absorbing the electron, and we can get a number of fragment patterns. So on the basis of such kind of collision, it is takes place by using a number of methods. So mostly in MCQ, such kind of question is asked, because now the pattern has been changed in the exam. So you must think. MCQs are so many MCQs we can find out on a single paragraph. So you must think like that. So your imagination power is now you have to increase, because in regular exam it is a straightforward exam. Everyone know the long questions, short questions, some bits are asked, and in that I have observed so many times. I have checked the university papers of MSc2 as well as MSc1. Then I have observed in bits students didn't get much marks, but in the question number 2 to 7 they can get a very good score. Now if the exam is in a MCQ pattern, then it is very challenging to you, that you have to go through the thoroughly to the all the elements on the basis of individual mass to charge ratio. That is takes place in second round of the mass spectrometry, and that's why it is called as MSMS. So MSMS is nothing but first MS is also there, and after that we can carry out each ion or each peak that is observed in the that ion particularly, that undergo further fragmentation. So it is called as tandem mass spectrometry, and it is mostly useful for sequential of proteins, nucleotides, nucleosides, that is carbohydrates, and that is almost matched with the database which is available in the computer software. So this sequence fragmentations can be organized in silico full length sequence prediction. That is, the softwares are available nowadays, and when we can check with respect to that, we can observe the peaks. So what is the basic diagram for this? So here, first we can take sample, it undergo ionization. Then by using this mass spectrometer first, we can get its separation, and here we can get a mass spectra of that particular. Now this mass spectrum of that particular compound, this ion is undergo fragmentation further. So each ion is undergo fragmentation further. So we can just represent by this. So suppose you can say that it undergo further fragmentation, and that is passed in the collision, that having a number of methods are there. That is CID, FID, or HCD, ETD. So different methods that can be applied over here, and then we can get a second mass spectrum, and in that we can get a MS2 spectrum that gives more complicated, but that gives a fragmentation pattern. So that is nothing but by using a simple method, that is very easy. So it is just you have to when the such kind of question is asked in the exam, so you have to draw such kind of ray diagram for this. So this is a sample ionization is takes place. There are no so many methods are there that we have already seen in detail. Mostly they can use EI, ESI, MALDI. Then it undergo fragmentation, and then it pass through the analyzer. So we can get separation by Z, and here we can obtain a single ion. Suppose we can say this one, it undergo further fragmentation by using the collision photon surface, and that fragmentation is carried out by using the number of methods, that is CID, ETD, HCD, etc. And then it undergo further fragmentation, and that is again passed through analyzer and then give to the detector, and here we can get a second product ion. So these are the precursor ion, these are the product ion, and they by combining all these, we can get a spectrum in detail. So this is the tandem mass spectrometry principle, how they can be work. So did you understand what is the difference between normal mass spectrum and tandem mass spectrometer? That is mass spectrum. Yes or
Yes,
no?
sir.
So it is very simple matter, but no doubt whatever the methods are that we have applied, just we have to use twice or thrice. Okay. Now in this diagram we can observe the sample is injected into the mass spectrometer, it undergo ionization, acceleration, analysis, that is MS1. So ion from MS1 spectra are then selectively undergo fragmentation. Suppose we are interested in any one peak out of this, and you can carry out only fragmentation of that. It undergoes second stage of mass spectrometry, and that can generate a spectrum for that ion fragment. So here we can get a single for this single line we have obtained a spectrum. So that fragmentation pattern we can say that which is there, what is the probable final structure, that is very helpful by using MS2. So and that's why that can give confirmation of that particular ion. Now, how this tandem mass spectrometer sequencing is work? So by use of tandem mass spectrometry, two mass analyzers are arranged in series with collision cell in between. And this collision cell, it is a region where the ions undergo collides with gas, that is argon, neon, helium, that resulting in the fragmentation of the ion. So this fragmentation of particular ions, mostly in the peptide or in the proteins, they go to the peptide bonds formation, and the resulting daughter ions, that is bond should be break, and that can give daughter ions that having a mass that are consisting, known as molecular weight of dipeptide, tripeptide, tetrapeptides, polypeptides, etc. So that fragmentation pattern we can observe very easily, and that sequence is very helpful to know what is the probable mostly we know that the structure of protein is very complex, and then it is very difficult to find out. But when by using such a tandem mass spectrometry, it is very easy to find out the sequence. So no doubt it is very fast. No gels are required, determining the molecular weight as well as that allow the sequence formation. Then it can be used on complex mixture, including low copy. Then it can be detected post translational modification is also there, and high dropout capability. No doubt it having certain advantages. Mostly it is very advantage, but when we can see the disadvantage or some limitations, we cannot say that disadvantages, but it having certain limitations that its cost is very high, because we can use two mass analyzer, and that's why it is very costly to purchase. Also, analysis cost is also very high, because for single iron we can carry out fragmentation, and that's why it is very costly as compared to the regular spectrum. Mostly for mass spectrum, as far as the organic chemistry is concerned, I have paid 1500 for one single mass spectrum. So that cost is about 2 year back. So maybe increases, but such kind of thing is there, and that's why we require a collaborative work in research, because characterization of the organic compounds is very difficult to do. So that's why when we can do such work in collaborative with institute, then industry, or we can say uh, different universities, then it is very easy to use that instrument from their side, and we can just quote the name of that in paper. So that is called as collaborative work. So that is very easy to use such kind of technique. Okay, sophisticated techniques can be very easily used, otherwise it is very difficult. Now, mostly we can use gas chromatography or liquid chromatography, are commonly used, is attached to the pre-ms for separation, that are used when analyzing complex gas or liquid samples by ms. So that we have already seen, that lcms, gcms, ms. So that is nothing but before the mass spectrometer, liquid chromatography or gas chromatography is attached. So it is applied to analyze the thermally unstable or non-volatile molecules, mostly for biological fluids. So for this purpose, LCMS is commonly used. No doubt, GCMS is for organic point of view, but for biological point of view, liquid chromatography is commonly used. That is LCMS, MS. So it is used to analyze the volatile compounds, that is used as a petrochemical compounds that can be used commonly. Then LCMS and GCMS are also used different methods for analyzation of compounds, because they have used a number of analyzers. So on the basis of advancement of analyzer, they can be modified, or number of instruments are nowadays available. So in LCMS, the samples may be ionized directly by electrospray ionization, and in GCMS the sample is ionized by the or indirectly via EI, that is electron spray ionization. So high performance liquid chromatography is also commonly used for separation. So not only GCLCMS, but HPLC is also used to separate at initial stage, and then it passed through the MS or MSMS, that is called as tandem spectrometry, that is called LCMS or LCMSMS. So this is the majority for biological samples, which are liquid and non-volatile. So that samples can be easily separated and identify each peak very easily by using this LCMSMS or HPLC MSMS. So that is nothing but it is a tandem spectrometry. So just this is a part that we have left on last lecture, that is the tandem spectrometry, and no doubt we can use a number of analyzers. On the basis of that, that is triple quadrupole, we can use quadrupole ion trapper, we can use FTICR. So such kind of analyzers are used number of times, just that we can get the fragmentation in detail, that is called as then what will happen, or any because afterwards when we can take the spectrum after detector, we can get a spectrum, and that formation of ions which are observed on mass spectrum, that based on their molecular ion peak, fragmentation ion, rearrangement ion, metastable ion, then they can observe corresponding multiple charge ions, isotopes, as well as negative ions, that can be formed in that case. Now, the molecular ion or we can call it as parent ion. When the molecule is bombarded with electron with high vacuum in mass spectrometer, it is converted into the positive ions by loss of electron. That we everyone know that because we have seen in detail. So it is called as molecular ion or parent ion. So this is we can get molecular ion, and this represent the parent ion. So M is for molecular, and molecular ion is represented by plus and radical. So that is the representation of molecular. So in this case, the order of energy required to remove the electron, sigma electron required more energy as compared to non-conjugated pi electrons, corresponds to pi conjugated pi electrons, and very less is required for non-bonding or lone pair of electrons. So mm, that energy we have to observe. That is commonly we can use 70 electron volt for carry out such kind of fragmentation, that removal of electron. So most molecule shows a peak of molecular ion, that is the stability of which usually we can observe aromatic are more stable as compared to the conjugated cyclic polyanes, then alicyclic hydrocarbons, ketones, ethers, then corresponding hydrocarbons and alcohol. These are the molecular ions peak that gives the stability decreasing from aromatic to aliphatic to alcohol. Okay. Now, you can see the characteristic properties of this molecular ion. It is observed by intact of long enough to reach to the detector. We know that it is 10 to the minus 6 seconds are required, and this peak gives a molecular weight of the compound, because here we can that having the highest mass number, right? So molecular ion has a mass because here we can lose electron, and that doesn't give the mass, and that's why there is no change in the mass. So we can call it as molecular ion peak, that having the same mass of that corresponding molecular weight of the compound, so from which it can be generated. So the mass of molecular ion, it is very important parameter to identify the compounds. So why molecular ion peak is very important? Because it is having the same mass of compound, and that's why there is no change in the mass. So M plus ion, when we can observe, that indicate the exact weight of corresponding compound. So here molecular ion peak gives the molecular weight of compound, that is M by Z of molecular ion is equal to molecular weight of compound. Suppose we can take C2H5 plus, that gives the molecular weight of corresponding ethane. Okay, that is fragmentation pattern is there. Now we can see the some important features of this molecular ion pantine peak. So molecular ion peak in aromatic compounds is relatively much intense due to the presence of pi electron system. The unsaturated compounds can give more intense peak as compared to the saturated or cyclic molecules. Also, the absence of molecular ion peak means that compound under examination is highly branched, or it is a tertiary alcohol, fragmentation pattern is there, and primary secondary is very small molecular ion. So in some cases you can observe, as it is a molecular weight, then why cannot gives the very intense peak? Generally we know that in the intense peak is for base peak, but here the base peak is not always same to the molecular ion peak. In some cases we can get the molecular ion and base ion peak are same, but in so many examples are also there that the most intense peak is a base ion peak. So molecular ion peak is different than the base peak. So that part you already learned at the first year. Am I right? Yes or no?
Yes, sir. Yes, sir.
Hmm. So just we can go through some basic terms that we have, because last year you have learned, just this year we can going through that part. Actually this part is not much important as far as the analytical students are concerned, but you must know the aware the basic thing. Suppose you can say that some isotope compounds are mostly organic compounds having the that element having isotope. So such kind of compounds that also gives the M plus 2 peak along with the molecular ion. So chloro compounds are there. Suppose the molecule contain chlorine, then it can give M plus and M plus 2 peak, and that having the intensity is 1:3. This is very very important to remember which halogen is present. If it is M and M plus 2 peak for 7981, that corresponds to 1:1 for bromo, then that isotope is identified regarding the their intensity of the peak is also very important. Whether it is 1:1 or whether it is 1:3, that very easy to um, identify chlorine or bromine. So if we see here, fragmentation peaks, there are so many fragmentation peaks are available. In that case, the molecular ion peak is unstable, so it break into the smaller pieces. It may be in terms of radical, it may be further molecular ion peak, and then it undergo positive ions, they further undergo fragmentation. So that is, there are so many fragmentation peaks we can observe one by one. So it is not necessary always we can get free radical, we can get molecular ion or positive ion, it further undergo fragmentation. So if we see in that case, ethyl chloride, then it gives the parent ion by loss of electron, then here it undergo fragmentation, so here we can break, so we can get chlorine radical, and here we can get carbocation, that is ethyl carbocation. And in some cases also, what will happen, this molecular ion picks up the proton from this side to form HCl, and here we can get the radical cation. So such kind of structure is also observed over here. Similarly, if we see such kind of pentane, then we can observe the molecular ion peak is 72. So if this molecular ions are observed, so that indicate there is a number of fragmentation is takes place, and we can get a peak at different position with M by Z 57, 43, 29. So if you observe, this is a very intense peak. It is called as base peak. So the nodal molecular ion is here. That is indicate the molecular weight of pentane, right? So molecular weight of pentane is 72. So here we can get the peak of parent ion. It is small as compared to the base peak. So that we have to observe on the basis of highest intensity or most abundance. So the most intense or tallest peak in a mass spectrum, due to the most abundant ion, it is called as base peak. So that is the basic difference between the molecular ion as well as the base ion peak. Okay, so it is there should not be any kind of confusion regarding the molecular ion and base peak are always not same. So it may be different. So molecular ions are not always base ion, because base ion peak is nothing but the more intense or abundant peak which is observed in a spectrum. It is called as base peak. So did you understand the basic difference between the base peak and molecular ion peak? So molecular ion peak is at 72, but base peak is 43. So relative abundance we can observe it is almost very high with respect to the other peaks. So if you observe the M by Z versus relative intensity, then we can get mass spectrum of ethanol. So mass spectrum of ethanol, here we can get molecular ion peak. It is small as compared to the base peak, which having the more intensity. Okay, so that is around about 32 or 31 is the molecular ion base ion peak, right? So did you understand the difference between base peak and molecular ion peak?
Yes, sir.
Okay, so molecular ion, here we can get, suppose we can say that it is 46 with respect to this, and this is 31. So this is the base peak which is having more intensity. That is the highest intense or tallest peak is called as base peak, and molecular ion is the molecular weight. So which ion is fragment over here? Just think over it, how the base peak can be obtained. Okay.
Sir,
Now
maximum,
we can see the isotope ions. So it is the most pardon?
sir, maximum stability येते तिथे येतो ना बेसिक.
हाँ बोला.
सर मॅक्झिमम स्टेबल आयन भेटतो तिथे बेसिक मिळतो ना आपल्याला.
maximum.
स्टेबल आयन मिळतो आपल्याला तिथे बेस पीक येतो ना.
हो, जास्त intensity सगळ्यात जास्त येते त्या पिकची. Hmm. Now we can see the isotope ions. So most elements are having a mixture of one or two, because mostly heteroatoms are present in organic compounds. So they can be get the isotope peaks and the ions which are observed that contains two mass units. So if you see the chlorine or bromine both having isotope 35 and 37, while for bromine is 79 and 81. So in that case, we can observe 35 chlorine and 37 chlorine, then always ratio is 3:1. So if you observe regular chlorine is at 31, that is nothing but the you are thinking if the compound containing chlorine, then the M plus and M plus 2 peak is observed. What that indicate? Suppose you can say the molecular weight of that compound is 256, right? So that is because of the chlorine. Now we can observe 3 plus 2 peak also, and that indicate its ratio is 3:2 because of chlorine. And if it is bromine, then we can observe equal 1:1, and that indicate your compound containing bromine. And that is the beauty of if your compound containing bromine, then we can observe M plus with two lines. Okay. Such kind of compounds that mostly I have the heteroatoms in my research, so that were observed in I have observed so many times the ratio is 1:1 as well as 3:1. So that is very important thing. Isotope clusters are referred to as isotopic peak, and that are helpful to determine the presence of such elements in a molecule. So it is very easy to understand which elements are present in a molecule, uh, whether chlorine or bromine. So on the basis of peak, that can give the support for your that particular element. This is M plus 2. Almost we can get this is molecular ion peak 122 think, and that we have observed M and M plus 2 that having equal intensity. This is the base peak. Okay. So in this way, the isotope ions can be observed. Suppose if you can say that it is a chlorine instead of 2 bromo or propane or 2 chloropropane, how we can easily identify that on the basis of the molecular ion peak height of M and M plus 2. When they are equal, then we can say that it is 2 bromo. And when they are having a 3:1, so M plus is 3 times larger than M plus 2, then that indicate the chlorine element is present in a molecule. So do you understand how we can observe isotope ions? Okay, so it is very easy to when we can see the spectrum, then it is and that's why I prefer that each and every student in its project work they should do the all spectroscopic characteristics of particular compound, even though it is known or unknown, that doesn't matter, because you must know that whatever you have synthesized or you are isolated, that having the signal how they can be look like. So that is very important part. Now the rearrangement ions. So in the molecular ion, or once we can get bombarding of electron, then undergo further fragmentation, and that fragmentation ion one of is the rearrangement ions. So these are the fragments whose origin cannot be described by the simple cleavage of the bond in parent ion, but that results into the intramolecular or intermolecular rearrangement during the fragmentation pattern. So prominent peak is in the spectrum of diethyl ether is 31, and this is due to the OCS3, which is formed by the rearrangement of C2H5O plus ion. So here, mostly the commonly used rearrangement which is observed in the mass spectrometry is the McLafferty rearrangement, and just it is applicable to the carbonyl compound. And which is the one more thing in the McLafferty rearrangement, Anyone can remember at which position the proton is required in
Gamma position, sir.
with respect to carbonyl. Anyone can huh?
Gamma position.
कोणाला आठवते का? या आणि त्यानंतर त्याचं फ्रॅगमेंटेशन होत असताना एक ओलेफिन मिळतो आणि इकडे इनॉल मिळतो जो पुढे जाऊन कीटोन तयार होतो. बरोबर आहे. म्हणजे अल्डेहाइड किंवा कीटोन जो काय असेल तो. म्हणजे हे तुम्हाला मॅक्लाफर्टीची रिअरेंजमेंट जी ही मोस्टली टी वायला आहे, MSc1ला आहे, MSc2ला आहे, कारण ही बेसिकच आहे. हीच रिअरेंजमेंट बरेच वेळा आपल्याला पाहायला मिळते. कारण कॉईल स्ट्रक्चर आपल्याला माहिती आहे कुठलंही स्ट्रक्चर जे आहे ऑर्गॅनिक मॉलिक्युलचं हे कॉईल स्ट्रक्चर असतं आणि त्यामुळे त्यांची पोझिशन जी आहे ती ऍक्च्युली टेट्राहायड्रल असल्यामुळे ते रोटेट होऊन येतात आणि त्यांची जे डिस्टन्स आहे हे त्या ठिकाणी रिअरेंजमेंट करण्याकरता सुटेबल राहतात. म्हणजे जरी आपण ते पेपरवर एका लाईन मध्ये काढत असलो तरी तसं ऍक्च्युअली स्ट्रक्चर नाही. दॅट इज इन थ्री डायमेन्शनल वी कॅन ऑब्झर्व इट इज कॉइल स्टेप स्ट्रक्चर बिकॉज ऑफ द tetrahedral geometry of the carbon. So this is the alpha, beta, gamma. This is a gamma proton, and then it undergo such kind of rearrangement. We can get corresponding alcohol. That is enol is there, and we can obtain alkene. Okay. Now, as there are so many fragmentation patterns are there in the mass spectrometry, so by using fragmentation pattern, we can easily identify the structure of compounds. That is Stevenson's rule: homolytic bond cleavage, heteroleutic bond cleavage, alpha cleavage, beta cleavage. There is inductive cleavage, most commonly used retro-Diels-Alder cleavage, McLafferty rearrangement. Some effects are also there. Some eliminations are there. So no, there are so many reactions are carried out in this case, and we can get a number of fragmentation pattern. So there are so many cleavages are there, and it requires so many time to explain in detail. But for analytical point of view, you must know aware the McLafferty is sufficient, but you know how the peaks are obtained by using a number of fragmentation pattern. And also we can interpret the mass spectrum by using the double bond. We can calculate it. Nitrogen rule is there. Then isotopic effects that we can observe M plus ion and M plus 2. So such kind of rules can be applied to interpret the mass spectrum. In that case, even number of nitrogen get even molecular weight, odd number of get odd molecular weight. So on that basis, we can get a peak M by Z ratio that indicate whether a nitrogen is present or whether it is one or two. So such kind of rule you already learn at undergraduate as well as at the MSc1. If we see the applications, that is the last part of this topic, we can say it is useful for both qualitative as well as quantitative analysis, and it is useful for the structure illustration, detection of impurities. It is used for quantitative analysis, drug metabolism, clinical toxicology, forensic application. GCMS mostly it is very common used in analytical laboratory to study the physical, chemical, as well as biological properties of variety of compounds. And that's why it is a very commonly used instrument nowadays in laboratories. Then it is useful for qualitative analysis, that is determine the molecular weight we have already observed. It is the most possible technique to determine or confirm the molecular weight of compound that can be easily volatilized. Then it also find out the molecular formula. Then it is essential to identify the molecular ion peak as well as the exact mass. So on that peak, uh, there is a molecular formula as well as the weight of that compound is already displayed in the spectrum. And with respect to that, there is a 4-digit number is there. Suppose we can say that the molecular weight is, suppose we can say that 74. Then it is not exactly 74. It is gives 74.00 or 12, whatever number is there. So the 4-digit number is given, and that's why the accuracy is very high in this case. Then the determination of partial molecular formula that can be useful to determine by using this mass spectrometry, and that can determine the structure of compounds, that is bombardment of vaporized sample molecules with a high beam of electron that results into the fragmentation pattern, and large molecules can be undergo fragmentation with respect to the number of molecular ions, and that gives M by Z ratio of particular ion, and that can be displayed on the spectrum. Then in quantitative analysis, it can be determined the isotope abundance that we already observed. already seen the example of bromine. So traces studies with isotope that can determine the atomic weight of compound. Even it is useful for age rock and minerals. That is also not only in organic but also in inorganic. This is very useful. So isotope mostly composition of molecules are observed in the nature. So that's why the determination of age of rock as well as minerals that can be determined by using the mass spectrometry. So in study of original as well as nature of solar system, whole study mostly is carried out by using the mass spectrometry, and that's why it is very useful and it can be applied to the number of sectors that can be carried out. So then it is also useful to determine the isotope ratio. So that can be used for determining the individual component or concentration of individual component present in a complex molecule, uh, from which it cannot be separated quantitatively. Otherwise, it is very difficult. And that's why the tandem spectrometry is commonly used in this case. Then the differentiation between cis and trans isomer can be easily found out by using the mass spectrum. So it can be used to differentiate between cis and trans. Both isomers yield similar spectra, but are differentiated from the intensity of molecular ion peak for trans is much more as compared to the cis. So that can be very easy to determine cis and trans isomer. No doubt by using coupling constant J in NMR, we also find out whether the cis or trans isomer is present. Okay, so these are the quantitative applications of the. Now in physical chemistry also it can be applicable, that is to determine the useful in the thermodynamics, that is heat of evaporation can be determined. So to determine the heat of evaporation of high temperature compounds, the spectrum is collected and graph is plotted by taking ion intensity was on y-axis and temperature on x-axis, and they can find out the heat of evaporation very easily by using the mass spectrometry. Also it is useful to determine the heat of sublimation, that vaporize sublime solids into the ionization chamber of mass spectrometer, and it is recorded in which the obtained peak, that intensity is directly proportional to the vapor pressure of the sample. So on that basis they can easily find out, this is very important, that uh, obtained base peak or any peak intensity are directly proportional to the vapor pressure of the sample in the ionization chamber. So on that basis we can easily find out the heat of sublimation as well as heat of evaporation of the molecule which are undergo ionization. Then we can find out ionization potential, that is the minimum energy is required by bombarding electron to produce the molecular ion from the molecules of atom. So that is very important to determine the or to measure the ionization potential. It is also very useful to determine the ion molecular reaction that find used to study the ion molecules because once one part is undergo ionization to get fragment, that fragment is react with unionized molecule that is neutral and it undergo further fragmentation. So that is a kind of chain reaction is takes place over there, and we can get corresponds to the fragment pattern in detail. So that is the very important part to determine the ion molecular reaction. Also, it is very useful to determine the impurities which are present in very low concentration. That is nothing but they are in parts per million, and that can be detected by using the spectrometry. So the molecular weight, once you can provide of impurity that differ very easily from, because we know that which kind of impurities are present in a molecule, then we can find out at which stage we can having a compound, and along with that which kind of impurities probably they can be obtained, because from natural sources when we can collect the material, then we know that which kind of impurities should be there. So on that basis we can say that these peaks when they are observed in that case, then we can easily say that such kind of impurities are present in a molecule, and then we can isolate on that pattern. Now identification of unknown compounds, it is a very well known application, and comparing with the spectrum of standard compound, then it is very easy to find out the isomer. unknown compound. Then identification of proteins. It is very valuable tool in the study of structure and function of proteins. That is electrospray ionization, matrix, that is MALDI, associated laser dispersion or ionization are widely used ionization method for the uh, purpose of analysis of proteins. And it is proteomics particularly deals with the analysis of proteins, and that is a trypsin, such kind of protease are there, so we can easily find out its identification. So these are the mostly useful applications of mass spectrometry. So broadly, it is applied in the clinical testing, in the genomics, environment, geology, in whole these fields. Mostly the mass spectrometer is used. So in proteomics, it is used for the identify. Also, they can find out the mass of fragmentation of peptides. Also, it can detect the translational modification that can be takes place throughout before and after fragmentation. Then it can give the quantitative analysis of proteins or exact weight of proteins can be determined over here. Then monitor the enzyme reaction, as well as it can modify the reactions for protein synthesis or digestion. So on that basis they can carry out the number of modification in the chemical reactions are also takes place, that in fragmentation we have already observed. Now we can see the drug discovery. So for the determine the drugs and metabolism structures, we can easily find out the apply, we can say that apply the mass spectrometry. Then we can screen for metabolites in biological system is also very useful. Then clinical testing, that is the perform forensic analysis such as confirmation of drug dose or others, where there we can detect the diseases that can be useful for the clinical research. Such kind of no doubt in that they can use HPLC, GC, LC, MS is also there. So NMR is also there. So number of instruments that are used in clinical testing and clinical trial. Then genomics, that is the sequence of oligonucleotides, can be easily found out by using the mass spectrum. Mostly it is used here. Tandem mass spectrometry is commonly used. Then environment for test of water quality as well as food contamination takes place, that can be easily found out by the mass spectrometry. And then geological, that is the petroleum composition that perform carbon dating, that can be measured very easily by using the mass spectrometry. So this is the scenario of whole application of mass spectrometry, and that is very useful to understand. I think whole applications, so we have covered over here. And a basic thing that we have observed, that this is the topic of mass spectrometry. Mostly 11 12 standard lectures we have spent on that, and we can focus on whole analytical part that covered. Along with that, if you have any kind of doubt, no doubt, once this test will be covered, one one more test of this topic we will take on the basis of mostly the theoretically how we can write down the part. On one lecture we will take such kind of test for writing, and I will check how you can write the already you have submitted the your assignments, and few of them are not sending, or they having some problem. But we remember that if you didn't complete within that time, you should send on a message on WhatsApp that extension of the date. So probably always I prefer to extend the date if there is requirement, and then you can complete that one. So mostly why I have given such kind of home assignment, this is because they're having some marks in day-to-day performance. One thing. Second thing, that you should write down the whole part in your notebook, and that is very essential. And once you can write down all that things in your wording, then it is very easy to remember. And that's why it is very essential that each and every topic you have to focus, because we don't know at this stage, whether the exam is takes place in online or offline mode, whether it is takes place by using a regular pattern or by new pattern. So that's why it is very crucial time for us, both you as well as me, that we have to take precautions regarding how the exam will be there. So each and every lecture is very important from you. As I have observed, the number of is always going on decreasing. Again, there is problem of whether the Raj Kakri is there. So such kind of, if students are not present, then it is very difficult to understand the basic things, and then that reflect in your marks. Okay, so I think this topic today we have completed. If any kind of doubt is there, definitely you should ask. And also, whole material I have sent on your uh, Google Classroom. Also assignments are there. And after this we will take one more test. Just I will concern with the that particular PG coordinator, because of PG dean mostly, Hasbe sir, because they have given instruction after completion of each topic you have to take the test. Just I will ask them of how many marks I will take and how I will conduct, whether it carried out at regular lecture of my or any other time, that we have to check. Mostly when we can carry out such kind of test, then your video is always on, and you should write down in front of your mobile or laptop, and whatever part you can write down on that question, you have to submit it in terms taking the scan copy and submit it to immediate within that time. So that test, probably on next lecture you should prepare. I will ask to them, and if they can say that you have to take on a regular lecture, then on next, I think, which is the date, that is 5th October, I think, right? So 2 3 4, okay. So if there is a on next, okay. जर काही डाऊट असेल तर तुम्ही त्या ठिकाणी विचारा. आणि मला वाटतं आपलं 10 वाजलेले आहेत, आणि एक एंटरप्रेनरचं एक फंक्शन असल्यामुळे त्या ठिकाणी जायचं असल्यामुळे आता ह्यामध्ये ह्यानंतरच कोणाचं लेक्चर बहुतेक सावंत मॅडमचं असेल, तर ते घेत आहेत का चेक करा. आणि त्या व्यतिरिक्त जो काय तुमचा टेस्ट आणि ह्याबद्दल काही शंका असेल तर तुम्ही विचारू शकता. ठीक आहे. सो विल स्टॉप ओव्हर हिअर. आणि जर कोणी स्क्रीनशॉट काढला असेल, संख्या वाढलेली असेल, तर तो स्क्रीनशॉट ग्रुपवर टाकून द्या.
मला काय बोलले?